I'm going to be talking about building leadership class AI infrastructure with DGX SuperPOD and DDN. I am a technical marketing engineer with NVIDIA. My name is Jacci Cenci, and my responsibilities at NVIDIA are testing and validating our storage partners like DDN with our DGX architectures, DGX1, DGX2. So with that, I'm going to move into my presentation, and I'm going to talk about NVIDIA as an AI leader. We really work very closely with our researchers. We try to help them with their use cases for advancing auto, healthcare, manufacturing. And our technical marketing team, we work very closely as we test and validate these solutions to help them with their reference architecture white papers, so that we have a prescribed methodology for our customers to take this information and build these architectures in their own environment. And as you know, these models are becoming a lot larger, the data sets are larger, and so we really want to make sure that we've tested and validated these architectures so that you know they scale with your problems. So when we look in terms of exponential growth in computing demand, right now we're showing zettabytes at 2025, 160 zettabytes. How many know here what a yottabyte is? It's the only byte that was named after a Star Wars character. Okay, that's 1,000 zettabytes, and I predict we'll be more at yottabytes by 2025 than zettabytes. As far as AI research is concerned, many of you know about NIPS. It's now called NeurIPS. It's one of the biggest AI conferences with papers, and also CVPR for computer vision. Those are really great events to attend and look at those research papers. And as you can see, the papers submitted continue to go up in the amount of papers and the amount of research going on. And then again, AI model complexity is growing. So how many of you here have heard that natural language processing is a big growth area and that we need a lot of supercomputing power for natural language processing? Yes, you're all nodding your heads. So I'm glad that you agree with that, because there's a lot of research being done in that area. And I just want to start here back at 2015. This is an example of ResNet 50 version 1.5, and we're doing training here. And you can see it took us about 25 days in 2015 to do this on one K80. But as we move up the scale here in years, we've added new technology, and we've tested that technology along with our partners like DDN. We've added NVLink to connect our GPUs together. We've added tensor cores. We actually performed a machine learning test called ML-Perf for supercomputing from a compute perspective with DGX 2H. And this is our DGX with NVSwitch. It has 16 GPUs in it connected together with NVSwitch. We have a very large internal system with thousands of, it's a multi-node environment where we do a lot of our autonomous vehicle testing. As you can see, 6.3 minutes of ResNet 50 for training on ML-Perf at scale on Saturn V. And then when you think in terms of where we are today, this is DGX SuperPOD, and we are able to do that in 1.3 minutes. So pretty impressive scaling when you think in terms of where we were at 2015 on K80 to where we are with V100. And if there are any of you here that have never seen a Volta 100 or a T4, I carry them in my purse. I'll pull them out for you so that you can see them. I also brought some cards with you if you want to come visit me and learn more information. When you think in terms of today's AI data center, we're able to shrink that footprint down with very big savings for deep learning to 10 kilowatts. So 1/8 the cost, 1/60th the space, and 1/18th the power. So we're really looking and working with our customers to help you consolidate your compute environments. This is the SuperPOD with DDN storage. It's number 22 on the top 500 list. And it's very modular, it's very scalable. You can see how we rack the DGX2s in the rack. As I mentioned, our team does the validation and testing along with a really strong engineering team. Our backline engineering team works very closely to test all the components of these systems. And many people think that NVIDIA is a hardware company, but 2/3 of our company are software engineers and dev techs, and they work constantly to optimize our software stack. So we're writing software all the time, and our systems are writing software. Our software systems are writing software as well. I talked to you earlier about natural language processing. These models are growing so exponentially. When you think in terms of what enterprise companies need today, you have all this dark data. You have all these disparate data lakes. You need to move that in with technology like NVIDIA's Rapids, where you can ingest that information, billions of rows of information that you have that's dark data today, and move that into an environment where you can start to ask questions and you can build recommender systems. And you take all that unstructured data and ask questions of that data. And that's where we're headed with these models. And new models and new algorithms are being created every day that requires this DGX2 and DDN architecture to be able to compute, analyze, and store that information. When we think in terms of the advances in unsupervised learning, we're working very hard to be able to ingest that information, tag that information, put metadata on that information, and then very easily be able to look at that information in these very large corpuses. And these corpuses are growing, and they are very specific to the domain that you focus on. So as this labeled data increases, we're looking at technologies to do auto tagging, because manual tagging and labeling of thousands of rows of data coming in is very ineffective from a cost perspective. It costs a lot of money to have people manually do this labeling. So that's where the DDN AI 400 appliance with DGX SuperPOD comes in. As we look at these algorithms, as we look at this technology, we need a system like DGX SuperPOD. It uses EDR InfiniBand or 100 gigabit E network connections for performance, for load balancing, for resiliency. And then when you think in terms of DDN's parallel protocol, this allows you to the storage to actually access over 200 gigabits per second. And this exceeds the desired goal of 1 gigabit per second per GPU. The whole goal is you want your storage and your storage partner to constantly keep those GPUs fed. You spent a lot of money on the GPU. You want to make sure that that data is constantly coming in and being fed into your compute environment. And then having the scalability of being able to have these various building blocks and be able to configure those in the way that you need with all NVMe architecture is very critical, and that's where the DDN AI 400 appliance comes in. This just gives you an idea for those of you who want to get into more of the technical specs around the RAM, around the caching hierarchy, the internal storage, as well as the high-speed storage. I'm not going to go into detail here because of the interest of time. And I do want to lead into where DDN is today with the AI 400X. This is an all NVMe flash appliance, and this delivers the fastest performance for AI as far as the workflows that our customers require at scale. So these are just some of the configurations. It starts at 30 terabytes and moves all the way up to 240 terabytes. So you have those four various configurations. I talked to you about our team developing reference architecture papers. We do that in collaboration with DDN, and these reference architectures are available on the web. They talk about how we validated, how we tested, what kind of models we used, what kind of interconnect we used, what kind of issues we may have had or challenges. And those solutions, there are many essays at NVIDIA and here at DDN that can go into more detail. So please stop and talk to them about these turnkey solutions while you're here. And then finally, when you think in terms of our ability to have this complete architecture set up in DGX-ready data centers, these are some of the program partners that we have. Many of our customers will say, hey, my infrastructure's just not set up for InfiniBand. I don't have the expertise. And that's why these DGX-ready data centers are so critical. They're all set up, they have racks, they have expertise, and please reach out to them if you don't have the infrastructure on-prem, or you need to know how do I move from on-prem into the cloud from this architecture that you see here in the data, in the DGX-ready data centers. Again, please go out, find our reference architecture papers, reach out to us if you have any questions. I do want to talk a little bit about NVIDIA's GPU cloud, because you may say, well, how do they get that software stack? Today, from an OS perspective, we support both Ubuntu and RHEL, Red Hat Enterprise level, as far as Linux is concerned for the OS. We have 50 containers. You can go to our NGC cloud, which is a wonderful repository. When I talk in terms of all these dev techs, they've optimized these containers so that all you have to do is pull down the container. It has models, it has HPC applications, it has scripts for you for natural language processing and image classification. We have pre-trained models so that you don't have to start from scratch. And then we work with you with our industry specialists in medical imaging, intelligent video analytics, in FSI, in the various domains that you might be focused in. And these are just some examples of the containers that we have up on NVIDIA's GPU cloud. This is our DGX2. This is an exploded view. If you want to see a real one, please go over to our booth. The real one's sitting in the booth. Mark Skinner's there, one of our SAs, and Brian Dowdy, one of my teammates, and they'll go into detail for you about DGX2, and you'll be able to actually look and feel, and if you want to see a Volta that isn't under cover, so to speak, I have one in my laptop bag here. Finally, we're offering a DGX2 natural language processing solution bundle. So if you're trying to develop a chatbot and you are also developing digital assistants, This need is really going to climb over the next 4 years. We have those available to you. Many of you may have heard of BERT or even BioBERT from our GTC in DC. We are able to train BERT in 2.8 days on DGX, on one DGX2, and with 16 DGX2s, just under 4 hours. So that shows you how it scales. These are some of the components of the solution bundle. DGX2 system, 3 years of support, the Natural Language Processing Deep Learning Institute. I'm certified for deep learning. We have deep learning stations over at our booth, so if you want to do some self-training, you can do that. And then, come to us if you have any questions about our Deep Learning Institute. So thank you all. I appreciate everyone coming in and listening to me. If you have any questions, I have some business cards. Please come up and see me.
Okay.
Have we got the benchmarks on Magnum IO yet?
Yes, we are working very closely with our partners. With Magnum IO is our, we just announced that on Monday. That's GPU Direct for storage. And what that allows us to do is move from our storage environment directly to the GPU. So the goal is you have direct memory access capabilities on your GPU. You want to remove that burden on the GPU, and you want to be able to use direct memory access on all the components internally and externally on the system. And that's additive for you. And so with the NVMe storage capabilities, you're able to get a 20x performance increase with Magnum IO. And we are continuing to do benchmarking around that.
Will we see results?
You will see results. We'll publish those as they come in. We're working very closely with engineering to publish those as we speak. Good question.
Perfect. Anybody else?
Any other questions? Yes. For the data center ready partners, there you are. These are the ones on the right side. We have Scale Matrix, who's here on the floor. Many of you have probably seen their ability to put DGX2 out in the field. Go visit them. We have Cirrus One and Flexential. We just did a big announcement with Flexential just a few months ago. So please reach out. We use the Vantage data centers for our reference architecture lab that we're building. Our team is very much involved in building a reference architecture lab in Santa Clara, so come see us. It's at the Vantage data center.